All right, ladies and gentlemen, we're going to continue with our discussion on how electrons fill up the electron cloud by today discussing what we call electron configurations. This is a list that shows where all the electrons are in an atom. That could be a neutral atom or an ion. It has to follow the off-ball principle, the filling order that we talked about in the previous lesson, 1s through 7p, following through the electrons as if they were the atomic numbers on the table, hitting the blocks and remembering that the S's start with 1, the P's start with 2, the D's start with 3, and the F's start with 4. We need electron configurations to help us see where the electrons are in the atoms, especially the number of electrons that are in their outermost energy level, their valence electrons, because those help determine the properties and the number of bonds that an atom will make. If you look down below here, the one thing you will notice that is added on that was not here previously are these superscripts. So let's talk about what the number, letter, and superscript mean. Okay? So when we look at an electron configuration, what I want you to realize is that there are 3 components to each little block of the configuration. There is a number out front that shows you the energy level, the letter S, P, D, or F that tells you the sublevel, and then the superscript tells you the number of electrons in that sublevel. This number will always be the maximum until you get to the end of your configuration. The very last piece of your configuration may have a number less than its capacity. If you think about why that is, off-ball principle tells us lower energy sublevels have to be full, so the 1s has to have 2 electrons before the 2s can get any. The 2s has to have 2 electrons before the 2p can get any. So these numbers are all at the capacity of our sublevel until we get to the end. The last one may have its full capacity, or it may be something a little bit lower. Remember that as we go through, S's can hold up to 2, P's can hold up to 6, D's up to 10, and F's up to 4. So let's take a look at some examples. Let's start at the very beginning. So if we start off with hydrogen, we need to figure out the number of electrons. It has an atomic number of 1. It's a neutral atom, so it has 1 electron. The lowest energy sublevel, the start of our filling order, if we look at our periodic table, our first electrons always go into the first energy level S block, the 1s. The 1s sublevel with hydrogen is going to take that 1 electron, and it's going to be right there. If we look at helium, atomic number 2, it's neutral, has 2 electrons. We fill in the 1s first, so the 1s is where the first 2 electrons for any element go. Both electrons can fit into the 1s. We end up with 1s2. What about, let's look at lithium next. Lithium has atomic number of 3, so it has 3 electrons. The 1s, which always fills up first, think about your filling order, 1s first. It can take 2 of the 3 electrons, which means that the next sublevel, which is the 2s, can take the last remaining electron. So then what about beryllium? What would beryllium have? If Be is atomic number 4, it has 4 electrons. The first 2 electrons always go into the 1s, 1s2. 2s comes next in our filling order, 1s, 2s, 2p, 3s, 3p, and so forth. 2s comes next. 4 electrons, we put 2 in already. The next 2 go into the 2s, and then we're done. So if you think about how we deal with this, the number of electrons should always equal the sum of all the superscripts on your sublevels. Let's mix it up a little bit, and let's move over to nitrogen. Let's move over to nitrogen. Nitrogen is in the P block, it's in the 2p, and it's the 3rd element in. So the element, how many boxes in it is, that's going to be the superscript for your sublevel. So in other words, nitrogen will have a configuration that ends in 2p1, 2, 3, 2p3 if we fill in those 7 electrons. Let's take a look at nitrogen. Nitrogen has 7 electrons. The first 2 electrons go into the 1s. The next 2 electrons are going to go into the 2s. After 2s, we run into the 2p. And how many electrons do we have left? 7, 5, 3. 3 of those electrons, the 3 electrons we have left, are going to go into the 2p, and then we're done. 3 plus 2 plus 2 is 7. All right? Let's look at another element here. Let's look all the way down to, let's go to chlorine. Okay, so chlorine is number 17. It has 17 electrons. 17 protons, 17 electrons is neutral. So the first 2 electrons are going to go into the 1s. It'll take 2. Takes us down to 15. 2s can take 2. That's down to 13. 2p can take 6. So we're at 10 of the 17. 10 of our 17 electrons are already counted. What comes after 2p? If we look at our periodic table, 1s, 2s, 2p, 3s. So 3s comes next. It can take 2 electrons. What comes after 3s? The 3p. How many electrons do we have left? We've used 2, 4, 10, 12. We have 5 left. That's the configuration for chlorine. Now let me show you a neat trick. So it ended in 3p5. Find chlorine on the periodic table. What sublevel is it in? 2p, 3p. How many boxes over is it? 1, 2, 3, 4, 5. 3p5 is the end of the configuration. All right? Let's look at one that's a little bit longer that has a D, some D electrons in it. Let's go for, let's go to arsenic number 33. Arsenic number 33 is in the 2p, 3p, 4p, 1, 2, 3. 4p3 should be the end of our configuration, which means everything before that is going to fill up. So let's go arsenic, which is As, 33 electrons because we have 33 protons in the neutral atom. We're going to put 1s2, takes away 2 of those. 2s2 takes us up to 4. 2p6 takes us up to 10. 3s2 gives us to 12. 3p6 gets us to 18. 4s2 gets us to 20. What comes after 4s? 3d10. That takes us to 30. We have 3 electrons left. Where are those 3 electrons going to go? Into the 4p. 4p3. What did we say the address of that was? Let's look at our periodic table again. 2p, 3p, 4p, 1, 2, 3n. 4p3, and that's where we ended up with our configuration. I want to do one more that includes an F block, and then I'm going to have you go and try to do several of these on your own with the attached worksheet. So let's go with lead. So Pb, that's lead, that's number 82, atomic number 82, so that means it has 82 electrons in its neutral atom. If we look at lead's location on the periodic table, it's right here. We're in the P block, we're in the 2p, 3p, 4p, 5p, 6p, 2. 6p, 1, 2 elements in. So we're going to go 6, everything's going to be full through 6p2. So 1s, 2, 2s2, 2p6, that gets us 10. 3s2, it's 12. 3p6, that's 18. 4s2, that's 20. 3d10 gets us to 30. 4p6 gets us to 36. After that we hit 5s2, 38. 5s, 4d10. 4d10 gets us to 48. 5p6,
takes us to 54. After 5p6, we're going to have 6s2. What comes after 6s? 4f. We go all the way through there, so there's 14 of them to get to that point. So we're at 70 of our 82. Our 5d10 is going to take us to 80 of our 82, and then 6p2 is going to be our end. All we're doing here is taking our filling order, and we're filling each sublevel to its capacity until we run out of electrons. And when we run out of electrons, like we did here for nitrogen, 7 electrons available. The first 2 go into the 1s, then 2 go into the 2s. That left us with 3 electrons not placed. They go into the 3p. Remember, the only one that is not going to be at capacity is going to be your last sublevel. Everything before that is going to be filled up. So what I would like you to do is I would like you to go through now and do the odd numbers on electron configuration worksheet 1. Do your work on either the printed out worksheet or on a piece of notebook paper. Scan and submit your work for that electronically, and we'll go through those answers tomorrow in our conference discussion.